Okay, now for this part that goes from achieve to merit is because you've got to create the equations. Then you've got to go through all the phases that you did with the A in creating feasible regions and then finding points of intersection and so on. So it takes a long time. This one is arranged extremely friendly, to be honest. It talks about the constraints quite clearly. A furniture store always sells 2 sizes of beds. Now, if you don't want to use S and D, which is what they've done yet, you can use X and Y. But just be consistent. Whatever you decide to do, just do it. So you should say X is single and Y is double. Okay, just indicate. If you don't want to use S and D, obviously if you use S and D, it's obvious what you're using and it's no big deal. But make sure you identify what you're doing and keep it consistent all the way through. Now, a single bed requires a display area of 20,000 X plus 40,000 Y, and the total floor space available for beds is 1,200,000 square centimeters. So it can't exceed that. So it's got to be less than equal to that crazy number 1,200,000. All right. Now, just a hint, guys. Don't use this crazy friggin' big equation. I mean, there's just no reason to do that. You've got all these zeros. Just eliminate them. So I've got 1, 2, 3, 4. Just eliminate them. 1, 2, 3, 4. Eliminate them. Get them out of the mix. So you're left with less than or equal to 120. Now you can reduce that even further by dividing everything by 2. But don't use great big equations. It's not necessary. I mean, these are equivalent statements. You've just divided everything by, 10,000 or whatever. And the thing is that that's a much more doable equation. And you can even, again, divide it by 2, and you get X plus 2Y is less than or equal to, 60. Make your life simple, all right? Don't make life complicated. So that's the first equation. The second equation, the owner wants to display at least twice as many double beds as single. Double beds was my Y. And it wants to display at least, so greater than or equal to, twice as many double beds as singles. So that equation is that Y is greater than or equal to 2X, meaning that this is where people get into trouble with this one, because they want to make it X is 2Y, but it's not. At least twice as many double beds as single. So Y is equal to, all right, twice X, double X. And it wants to have at least 2 single beds, X, on display. At least. Okay, so at least 2 on display. Okay, now we've got that. So we've got now 3 equations. And then we talk about another constraint, which is discount. And the bed manufacturer offers a discount of $40 for each double bed and $70 for each single. So 70 X plus and 40 Y, 40 double beds for each, $40 discount for each double bed and 70 for each single bed, up to a maximum discount of $1,400. So less than or equal to $1,400. And again, you don't have to have this great big thing. You can get rid of these zeros when you go to write it. So you can have 7X plus 4Y less than or equal to 140. And you can deal with that equation. And so these are all the constraints. We've got them all down. Express these information as a series of constraints, simplify the constraints, and graph them on a set of axes, shading out the feasible regions. I am not going to go through that whole process again. I've just shown you how to do feasible regions and graph these things. This is your turn to do that now.